Happy New Year. So this is 1st January. Let's do some LeetCode on 1st of January. And as you can see, we have gone through a lot of questions here, but I still need some time to, actually find how to say this, basically revise all these questions. I'll maybe stream one day and I'll revise all these questions. So I have now and we can, whether this cat YouTuber application that I'm using right now, I'll actually make a process is a 3D model of the avatar of the channel, and then try to use that as a VTuber model sometime later. But for now, I'll just use this. Okay, next, let's go to the question of the day for the 1st of January. It is this: assign cookies. Now, I'll just simplify the question for you. Basically, we have an array called GeoFi, which basically has a list of all the minimum sizes of a cookie that a particular child is ready to eat. So that's the minimum size. If you don't, if you give a size which is smaller than the minimum size that is given in that array, then the kid won't be satisfied basically. And your task is to make sure that most of your kids are content or satisfied with the cookies that you're giving. So G array has the greediness, or basically the minimum amount of or minimum size of the cookie that they want to have, and S array contains the actual size of the cookies that you have. Now let's go to the whiteboard and try to solve this. So if I were to use, if I were to go with this example here, there's only one way to satisfy the maximum number of kids, which is to basically let me just quickly write this down. Yeah, there we go. Which is to basically give the first child one cookie. There we go. And since the second child needs a cookie of minimum size 2, we can't really give this particular cookie to him because he or she would not be satisfied. They would not be satisfied basically. I'm being really neutral here. So as you can see, if we really need to sort the array, because if I were to take this example, let's say we have 1, 2, 3 and 4, and I am starting with 3, 2, 6. Okay, now if I just use the first cookie or give the first cookie to the first child, then I'm basically giving a huge cookie to a child who doesn't really want that. 2, 2, 2, okay, good. 6, again, I'm giving a huge cookie to number 3. But the best way to make sure that all the children are content would be maybe to put this to 4, give 2 to 2, and give 3 to 3. So the first one will not be content. I know it's a number of content children is still the same, but at least you have optimized it. But you can understand that sorting is necessary. For example, if I had 0, 3, 1, then I can't just go to 0 and then assume that there are only there are cookies with size 0. I know this is not possible, but I'm just giving you an example. And if I give 3, this is getting really messy. Wait, if I give 3 to 1, then I have one remaining, a cookie of size 1, which could have been given to 1 instead of giving 3, and this one would be given to 1, and this 3 could have been given to the second child. This way, you have to make sure that these two arrays are sorted. So the approach basically involves using 2 pointers. I'll just go right. Basically, what will happen is this is the greedy array 1, 2, 3, and this is the size of the cookie array 1, 2. Okay, so there will be one pointer here, and there will be one pointer here, and if there's a cookie in the S array which satisfies the child, then we'll move the pointer to the next one, and we'll move this pointer to the next one as well. Again, let's do that, and then we'll move to the next pointer, next index. If there's nothing, we don't have any cookies remaining, or if we reach a point where there are no children remaining, then again we reach a point where we don't need to do anything anymore, and we can return the value of I. So 0, 1, 2, right? So value of I would be 1 here, which is like +1, 2. So basically value of I is 2, which means that we have satisfied 2 children. So this way we have to basically get the index which is used to iterate over the G array. Now let's look at the how does this the code. The thing is, I have actually written the code in advance just to save time. So you'll see that it's already there. There we go. So let me just show you the example on the left hand side. So what I'm doing here is, first I'm making sure that the arrays are sorted. Okay, I hope the captain is not isn't a problem here. We just move it a bit. There we go. So as you can see here, we have first sorted everything, and then I'm taking I, j, 0, while I is less than length of the he is again the the greedy or the minimum size every child wants. So while I is the cost for a particular child, so the required size of the cookie for a particular child is less than if it's less than the size of the actual cookie, then we will increment the index by 1, which is basically we found a cookie which can satisfy less than or equal to. If we found a cookie that basically can satisfy the child, so we'll move on to the next one. And this is just to check if I have reached the end of the array, so that we can break out. And this way we can just I plus 1 j plus 1, just like I showed you in the whiteboard. And then in the end, we'll return I. And this is quite efficient. If I submit it now and see. Yep, it's quite efficient. As you can see here, the time complexity is really good. And the squeeze complexity is, I mean, yeah, sure. You can work with this. Then I will see you in the next one. Bye.